All right, guys, good afternoon again. So let us begin. So we are following through with the vectors, and we have now gotten to the section where most of the question, this is what you'll be mostly tested on, what we're gonna do next, which is not a lot, right? Not a lot, but it's what your questions are mostly centered around. Right, the first part of it, or let me put it this way, it is the part of it, it is part of the lesson that if you can understand this part of the lesson, then you'll certainly be able to answer the question. The first part of it that we did yesterday, relatively basic and almost common sense, and you'll see that when we start doing the question. Remember, at this level, vectors is really, for the most part, how you get from one point to another point. All right, going along vector directions that you know. Right, so they give you two vector directions, and then you want to find some path, do some displacement between points using those vector directions that you know. And then they're gonna ask you about parallel vectors and collinear points, and they're gonna give you some relationship between the length of lines and stuff like that. So we'll see all those things when we start doing the questions. All right, but the first thing we're doing today now is what we have on the screen there, which is parallel vectors. Parallel vectors. All right, so they'll test us on parallel vectors for sure. What are parallel vectors? As it says, parallel vectors going in the same direction, but they don't have to have the same length. So really and truly, it comes down to a length relationship. So they have the same direction. These are vectors with the same direction, but they don't have the same length. Equal vectors are parallel to, equal vectors are parallel, but equal vectors have the same length. Here now we're talking about, we're mainly focusing on vectors that have the same direction, but they don't have the same length. All right, and there's one key thing now. So we can start by showing those two vectors now are parallel. So if you look at the diagram, we have the vector AB. I'm going to extract a parallel vector from AB, which is PQ. So those two vectors are parallel. They have the same direction. And the difference between them is magnitude. And therefore, what it is that one is longer than the next one. And because the direction is the same, then one of the vector is a multiple of the next vector. Right? And then both of them can be expressed in terms of a unit vector. But we're not going to speak too much about unit vector now. Let's just understand the basics first before we get into unit vectors. So when two vectors are parallel, one can be expressed as a multiple of the next, and that is what you'll be required to do in the exam. Show that one vector is a multiple of the next one. So for example, what we have the vector AB and we have the vector PQ. If they are parallel, then AB might be equal to something like 2 times PQ. If you are able to show something like that, that one of the vector equal a multiple of the other vector, then you would have shown that they are parallel. That's all you have to do. And there are a number of steps I'm going to take you through to prove when two vectors are parallel. All right, I'm going to show you a number of steps that you can use to show when two vectors are parallel. But let us complete the slide. So that's what we need to show, that AB is equal to some constant times PQ. Some constant value times PQ. Now that constant value can be a fraction, can be a whole number, can be positive, it can be negative. If it's negative, it just means that the direction is opposite, but then they are still parallel lines. Just that the direction will be opposite. If that constant is negative, K I'm talking about now, if it is negative. So that's what you want to do when you're asked to show that two vectors are parallel. And furthermore, if they tell you that one vector equals a constant times the next one, then automatically then you also know that they are parallel. So what it means, what I mean by that, is that this implies that they are parallel. And you can go the other way. If they are parallel, then you are supposed to show this. All right. So this means this, and this means that. You have to understand it both ways. Don't just always think of it as a one-directional thing. If they're parallel, then one is a multiple of the next. If what you know first is that one is a multiple of the next, then it means that they are parallel. If the question says show that they are parallel, then you basically have to show that that one is a multiple of the next. That's how you show that they are parallel. All right, and as I said, there are steps that we're going to learn to show that they are parallel. So that's what it means. AB is parallel to PQ. AB is parallel to PQ since AB is a multiple of PQ. They might also ask for another relationship between the lines, and the other relationship is a relationship of the length. How long one is more than the next one. And oftentimes what they'll do, they'll ask you to show it as a ratio. So now you want to compare the two lengths, because oftentimes in the question they'll say, what is the relationship between AB and PQ? One relationship is that they are parallel, and you show that by showing this. And then another relationship is how long one is more than the next, or what is the ratio of the length. And we talk about the length, we're talking about the magnitude. Remember, length is magnitude or modulus. All right, so you want to compare the modulus. So what we usually do, we take the modulus of both sides of the vector equation. So this vector equation, we take the modulus of both sides. Because if this equals this, then the modulus of this side equals the modulus of that side. That's the concept. Right? And so we're getting down here from that. Take the modulus of both sides. And when you take the modulus of both sides, what that does is that if this is negative, you make it positive, because length cannot be negative. So for example, suppose the K was -2, and you take the modulus, then it will just simply become 2. And then also you can drop off the arrow. You don't need direction again. And you end up with AB, for example, equals K times PQ. All right, I think it's on the slide. So let me just show it. All right, so you see I drop off the arrows now. So I drop off the arrow. Remember that if the K was negative, you write it now as positive. All right, because length cannot be, length don't have any direction. All right, so you drop off the arrow because you're now talking about the length. And you can divide one length by the next length. So you can divide, for example, the AB divided by the PQ. And the AB divided by the PQ, see here, AB divided by PQ will be equal to K. But because you want to show it as a ratio, you put it as Q over 1. Q over 1. All right. And when you have that ratio, you can write it as a ratio like this. AB to PQ is K to 1. AB to PQ is K to 1. And oftentimes, you have to show relationships like this. And sometimes they'll give you relationship like this. And we're going to see that in some questions. So that's when they are parallel. So when they are parallel, one is a multiple of the next. And then you also can have a relationship of the length, which can be expressed as a ratio of the two lengths. All right, this is something that we have to do. Let's look at an example. So let's say we have those two vectors. All right, before I get to those, write down this for me. I'm going to dictate something and write it down for me. To show that two vectors are parallel. To show, what are the steps? To show that two vectors are parallel. This is very important. Show that two vectors are parallel. First step. What you have to do in the first step is get rid of any fractions. Get rid of any fractions in the expression. Get rid of fractions from the two vectors. So you have two vectors, you want to show that they are parallel. First thing you want to do is get rid of fractions from the two vectors. So that's the first step. Get rid of any fraction, or get rid of fraction. That's what you want to do first. Get rid of any fraction. Anybody can tell me why I would get rid of fractions first? As a first step. Anybody have an idea why we'll do that?
Because you can't have a ratio that has a fraction in it.
No, that's not the reason. Because you could have AB to PQ equals 3 to 2. So it means that AB to PQ would be 3 to 2. I'm talking about the individual vectors. The individual vectors I'm talking about. So for example, you might have the two vectors. AB, vector AB equals half, say half V minus 3 over 2u. That's what I mean. So when the vectors have fractions in them, that's what you want to do. You might have another vector pq equals say, let's make it simple, 2v minus 6u. So you have those two vectors. You have to get rid of the fractions out of this one. That is one vector fraction. I want to get rid of those fractions. So what do I do? Why do you think I'm getting rid of fractions? Remember, and then in the day, I'm trying to show those two, one as a multiple of the next thing. That's what I'm trying to get to. The first step is that I get rid of any fractions. All right, you don't know. Let me tell you why I get rid of fractions. It is harder to see the relationship between numbers when they are in fraction form. It's easier, for example, to see the relationship between 6 and 3. Two numbers like that. The relationship between 6 and 3 is that the 6 is equal to 3 times 2. It's easy to see that relationship, whole numbers. But if I give you 2/3 and I give you 5 over 4, it's more difficult to see the relationship between those two fractions in terms of saying which one is what times the next one. You understand what I'm saying? That's why we get the fractions. It's harder to see the relationship between the vectors when they are in fraction form, when they are expressed with fractions. So that's why we get rid of fractions first, because we're trying to see the relationship between them. So that's the first step, get rid of any fractions. After you get rid of the fractions, the second step is that you multiply up the small vector to make it equal the larger vector. So after you do that, you multiply up this smaller vector to equal the larger vector. Like this, the larger vector. Multiply up the smaller vector. I'm gonna copy this down so we can use it. Copy this down. Cut it and put it down here. Right. So multiply up the smaller vector to equal the larger vector. All right, that's what you do next. And after you multiply up the smaller vector to make it equal the larger vector, that means that the two vectors now equal. Third step is you equate them. Equate and simplify. Equate and you simplify them. All right, so let me show you this example down here now. So I have these two vectors, and I want to show that they are parallel. All right, I want to show that they are parallel. First thing I do, I get rid of the fractions. So the one with the fraction is this one. That's the only one fractions. What would I have to multiply this by to get rid of the fractions? Look at it.
Half.
Two.
Half. 2.
Four.
Like,
4.
yeah, but you want to multiply by the lowest common multiple that will get rid of the fractions. You understand? You understand me? The lowest value that will get rid of the fractions. So the lowest value that will get rid of the fractions is 2. Right? So multiply it by 2. But somebody said 4. Eventually, I multiply 4 would work, but I just showing you some things. I just going step by step. Remember, I just show this out of my head, So if I multiply this one by 2, multiply 2 by 2, then this fraction will be gone and this fraction will be gone. But remember, you have to multiply this by 2 as well. So the vector becomes 2 times the vector AB equals V minus 3U. So I'm now comparing these two. What is my second step? After I get rid of fraction, what I do? I have to multiply up the small one, multiply up the smaller one. Another way you can do it, you can factorize a large one, but I'm telling you, it's easier to multiply up the small vector, multiply up the smaller vector to make it equal to the larger vector. That's the second step. I'm giving you 3 steps. You're not going to see these 3 steps in any book. So you have to remember them. So of these two now that I'm comparing, which one larger, which one smaller? And we're talking about the vector components now, these sides. Which one larger? The AB or the PQ?
PQ.
Which one smaller? Smaller, I should say. Which of these two smaller? This
2AB.
2AB is smaller. Good. 2AB is smaller. So that's the one I need to multiply. So what do I multiply it now by to make it equal the large one? Multiply by 2. Good. So if I multiply by 2 now, then it becomes 4AB equals 2V minus 6U. And what we have now is a case where they are now equal. So this is equal to this, and this is also equal to this. So since both of them equal this, it means that these two now equal. So that's why we said the third step is to equate. So reach step 3, which is to equate. So now we're going to equate. Now when you equate, you're going to get that 4AB equals PQ. Or if you like, you can write PQ equals 4AB. This means that they are parallel. So we can say, therefore, PQ is parallel. That's the symbol for parallel to AB. Because we have expressed one of them to be equal a multiple of the next. So when you express one as a multiple of the next, it means that they are parallel. Now, which one of them longer? The PQ or the AB? Which PQ longer? In fact, PQ is 4 times the length of AB, don't it?
Yes,
so this
sir.
is one good. So this is one relationship between them. This is one relationship between the vectors. And a second relationship between the vectors is that PQ is equal 4 times the length of AB. But to show that now, what you do, you take the modulus. So we'd say the modulus of PQ is equal to the modulus of 4 times AB. You take the modulus of both sides. That's what you did. Take the modulus of both sides of that. And what that does is take all the vector component, remove the arrows. So we'll end up with the length of PQ is 4 times the length of AB. That's what you have with all the arrows. So that means that PQ is a length of PQ is 4 times the length of AB. So this is a second geometric relationship. So this is a first geometric relationship between the two lines that they are parallel. The second one is that PQ is 4 times the length of AB. Now, some persons would not put in this step, but I would like you to practice to put in that step. We take the modulus of both sides. Some people just jump from here to there. But I prefer if you show this step. Let me tell you why. Now, if we do it another way, and this came out to be negative 4 AB, and this is negative right there. When you take the modulus of a negative, you would drop the negative. You wouldn't put it back because modulus means it's just a length. It's just a length. The negative here would mean that the direction is opposite. It means that PQ and AB will be heading in opposite direction if there was a negative there. All right, that is what would happen. And you would still end up with this. You'd have to drop the negative because now this one is talking about the length of the line, and length cannot be negative. All right, that's what you'd have to do. So that is it. Sometimes they might want it to express it as a ratio. So they want this as a ratio. They want us to express it as a ratio. And what we would do is the PQ divided by AB. We divide the AB under here. I would say we divide both sides by AB. Divide both sides by the AB. Anyway you want to look at it. And that PQ over AB be equal to 4. And 4 is the same as 4 over 1. And therefore, as a ratio, PQ to AB would be 4 to 1. 4 to 1 if you express it as a ratio. All right, that is that. Now, in this example over here, I did not multiply the small one to equal the large one. I just looked and I saw that this was actually just 2 times this. It's obvious because of the values, right? So based on that, I know that the MN is 2 times the RS. That means that the parallel, the method I used was to factorize this large one. So let's look at it. But from now on, I want us to work with these 3 steps. We'll multiply up the small one to equal the large one, all right? These 3 steps up here. That's what I want us to use going forward, all right? Get rid of any fractions. Why? Because fractions are harder. It's harder to see the relationship between numbers when they're in fraction form. Multiply up the small one to equal the large one. And when the 2 of them equal, you equate them. And if it can be simplified, you simplify. Sometimes you don't have to do all 3 steps. Like for example, over here. We don't have to do all 3 steps over here. Why would we have to do all 3 steps? Because there's no fraction there. And sometimes after you get rid of the fractions, then they are already equal. And they just skip out step 2. You just equate. We must always have something to equate. All right, you must always have something to equate. So some questions, you skip out step 1. Some questions, you skip out step 2. Some questions, you skip out both steps. Because you have the vectors equal already and just equate them. All right, so we see that we'll start doing examples. So look at this example over here now. This question is saying, they give us M and M. Vector Mn. Give us the vector Mn as that. And the vector Rs as that. And it says, show that they are parallel. Show that Mn is parallel to As. And then after we show that they are parallel, it wants us to find the ratio Mn to Rs. Show that the lines are parallel first. And then after we show that they are parallel, we must find the ratio. Same steps again. It's done differently on the slide, but you're still going to see that they're parallel. So that is it. What I did in this example was to write Mn as 2 times the 2, 3. What I did in this example was to factorize 2 out of this. That's how I used to teach it in the past. But I would factorize a large one. That's what I used to do. But now I find that students understand it better if we multiply up the small one. So in that case, what I would do is multiply up this one and get 2Rs equals the 4, 6. Right? And they would equate this now with this. Because the 2 of them equal to 4, 6. 2 of them equal to 4, 6, is it? 2 of them now equal to 4, 6. And so you would equate this and this in my new method. So the slide you're looking at is an old method where you used to tell the students to factorize the large one, but I've changed that. So my second step used to be in the past, factorize a large one. I find that it's easier to multiply up the small one. So I didn't change the slide, but I've changed the method. All right. So after you multiply up the small one, after you factorize the large one here, what you do now, you write it as that. Because remember now, what does that mean? Is that this 2, 3 is the same 2, 3 right here. And the 2, 3 is equal to Rs. So I've replaced that right there. All right. And so you now have that the Mn is 2Rs. That means that they are parallel. That means that they are parallel because one equals a multiple of the next. So that's how I used to do it in the past. Then to get the ratio now, what we do? Take the modulus of both sides. See, taking the modulus of both sides. So you get the modulus of Mn equals the modulus of 2Rs. And then that drop the arrows. You drop the arrows and you drop in the negative. There were negatives there. Then after you drop the arrows, what you do, you divide to get the ratio. So you put the Mn over Rs. You're left with 2. 2 is the same as 2 to 1. Therefore, Mn to Rs is 2 to 1. 2 to 1. All right. But understand that?
Yes, sir.
Yes, sir.
All right. So we're going to practice it many, many times. Several questions we're going to practice. So that's how you do parallel vectors. All right. Remember these 3 steps. Remember these 3 steps, guys. Very important. Remember these 3 steps to show that the vectors are parallel. When we come to collinear points, it's the same 3 steps we have to use. All right. When we come to collinear points, it's the same 3 steps we'll have to use. Because collinear points exist when you have parallel vectors with a common point. I think that's what we're going to do next. What comes next is unit vector. I'm not going to do unit vectors now. I'm going to do, because they hardly ever set any question on unit vector, because unit vectors is something that come on ADMATS. Unit vectors is on the syllabus, you know, but I don't see them setting any questions on the unit vectors, right? But what I'm going to do when we finish what they normally set, I'll come back and I'll go through unit vectors with you. All right, I'll come back and I'll go through unit vectors with you, but I want us to master what they normally set first, but I don't want to confuse you. I'm not going to deal with unit vectors just yet. But unit vector is very easy, but I don't want to deal with it yet. I can teach you the rest of it without doing this. So I'm going to skip this out. This is when unit vectors was more squarely on the syllabus. So I'm going to skip this out. So don't worry about this part for now. We'll deal with the unit vectors at another time. All right, we'll deal with this at another time. So I'm coming to the last thing that you need to know now, which is when points are collinear. What do we mean by collinear? Anybody know what I mean by collinear? Collinear.
There are 2 answers for, or
We're
1
talking
answer for
about
2
points.
equations.
Collinear points. Collinear points. What do we mean by collinear points? What do we
There are
mean by
2 points on the same line.
huh?
2 points on the same line.
2 point, but any 2 point can go on one line. So it's really about 3 points. So collinear points is when you have 3 points. Remember, you know, you can draw in the line through 2 points. You can draw in the line through 2 points. So we're talking about 3 or more points really. So when you have 3 points, you can draw a straight line through them. They are said to be collinear. Understand? That's what we're talking about. So now we're gonna look at cases when you have 3 points on a straight line, and we can use a vector method to show that 3 points are collinear. All right, we can use a vector method to show that 3 points are collinear. So that's what this is about. And I like to ask about collinear in the exam. So this is it now. To show that 3 points are collinear, look over here now. Look back over this side now. To show that 3 points are collinear, we need to show 2 things. 2 things you have to show the examiner. So the question said to you, show that 3 points are collinear. Another way they might say it is that state one relationship between, so for example, you have these points, right? On a diagram. And this point is A, this point is B, this point is C. Instead of saying, show that A, B, and C are collinear, the question might say, state one geometric relationship between the 3 points. State one geometric relationship between the 3 points. That one geometric relationship is that they are collinear, but you have to show it. You have to show it. How do you show it? Over here, we're now going to talk about how you show it. To show it, you have to show 2 things, guys. 2 things you have to show. Once you can show those 2 things, it means that the points are collinear. 1, you have to show that there are 2 vectors, show that you have 2 parallel vectors passing through the 3 points. 2 vectors passing through the 3 points. 2 vectors passing through the 3 points. And then now, when you have 2 vectors passing through the 3 points, then what you will also have is a common point. So that's what you have to show, that you have parallel vectors with a common point. You have to show that you have 2 parallel vectors with a common point, a point that is common on the 2 vectors. So for example, if I take the points A, B, and C, for example, then I might have a vector AB that is equal to 3 times the vector BC. This means that they are parallel, don't it? And the B is a common point because the B is on the AB and the B is also on the BC. So you have a parallel vectors. AB is parallel to BC, and at the same time, you have a common point on the two vectors. So an equation like this would satisfy those two things, because by virtue of one being a multiple of the next, it would mean that they are parallel, and then the common point is obvious there. That's what you have to show that you have collinear points. Parallel vectors with a common point. 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 I don't have to use AB and BC. You know. I can use AB and AC. And this might be 4. I just writing some numbers and I don't mind this number, just making up something. That might be 4. Still have parallel vectors. This time a common point is A. I might have BC and AC. So I might have AC equals 6 times BC. Then parallel, and there's a common point C on the two of them. Again, I would have A, B, and C will be collinear. All right, so let's look at it over here now. So in the diagram now, look at the diagram, guys. In the diagram, you have the vector AB, AC, and you also have the vector AB, and they are parallel. They are already parallel. So one is a multiple of the next. But if you look at the point A, you can't have two different point A on the same diagram. So that point A really is the same point, right? So since they are parallel, you know that the AC equals a constant times AB. But the A is a common point, right? So underline the A to show that it's a common point. So that line AB really should be on the line AC, right? The point A is a common point. It's common to both AC and AB. And so it has to be one place on the diagram. And so I move it and put it where it is. And that shows that the 3 points are therefore collinear. So once you have parallel vectors with a common point, it means that really and truly, the 3 points are on a straight line. 3 points are on a straight line. And therefore, that's all you have to do to show that you have collinear points. And that is it. Therefore, A, B, and C are collinear. Now, remember now, too, you know, it can be also a case where they give you a relationship and you have to know that the points are collinear. So if a question tells me, so question said, given that, what question said, given that PQ is equal to 3 over 2 PR, and ask me what is the relationship between P, Q, and R. It must be that they are collinear. Why? Why them collinear? Because I have parallel vectors. These are parallel vectors. Those are parallel vectors. But I have a common point P. There's a point P on that one, and there's a point P on that one. Why are these parallel vectors? Who can tell me why those are parallel vectors? The PQ and the PR. Why are they parallel? Somebody unmute the mic and tell me why those two vectors. If I give you this equation right there, why can I conclude that PQ is parallel to PR? Why is that? So 1.
Sir, because point A is common to P.
Oh man, look at the mask. Look what I'm asking. Listen to careful what I'm asking. If I give you this equation, a question, give you that equation, and I said, draw 2 conclusions. What are 2 conclusions that can be drawn from this equation? Given that the vector PQ is 3 over 2 times the vector PR. One conclusion is that they are parallel. Why? Why is it that they are? Why are they parallel? Why is it that PQ? Why is it that PQ is parallel to PR? Why?
Sir, because them are going in the same direction.
No, because 1 equals a multiple of the next. Simple as that. When 2 vectors are parallel, one of them equals a number times the next one. Simple as that. Once you have that relationship, one vector equals a multiple of the next vector, it means that they are parallel. That's the reason. You understand? So since PQ is a multiple of PR, it means that they are parallel. So let me write it out for you then. So the first thing, since PQ equals a multiple of PR, vector PR, then PQ is parallel to PR. That's it. This is the reason right here. One is a multiple of the next. That's the reason. When one vector is a multiple of the next vector, it means that the two vectors are parallel. All right. The second thing I can say is that I have a common point P. Common point P. So the next conclusion is since P is also a common point. What do I mean by a common point? Common point means that the P is on this vector and the P is also on that vector. That's what common point means. You have a letter, you have a point on the two vectors. Since P is also a common point, then P, Q, and R are collinear. Meaning that they are on a straight line. So if a question give me this, I can draw these conclusions. If a question asks me to show this, I have to show this, and I also have to show that. So the question can go both ways. Both ways. I can start from these and conclude that, or from this, I can conclude this and also conclude that. I can make those conclusions. So the relationship goes both ways. All right, that's it. Once one vector is a multiple of the next, it means that they're parallel. And if in addition to that, there's a common point. If in addition to that, there's a common point, it means that the points involved are collinear. All right, that's what happens. But let us continue. We're going to see it in a lot of questions, so don't worry yourself. All right, we're getting information gradually. It's a gradual process. You're not going to just get it right off the bat. All right, not going to get it right off the bat. So let's continue. All right. So, as I said, no, in addition to using the AC and in addition to using the AC and the AB to show it, you can use any two vectors from the 3 points. Any two vectors from the 3 points can be used to show that the points are collinear. So if you look at it now, I'm going to use some other points now. So if I'm using BC and AB down here, look, I'm using BC and AB. So look here now, up here, so I'm using AC and AB to show that they are collinear. And in that case, A is a common point. That means they are collinear. Down here now, I'm using BC and AB. But this time now, the B is a common point. See, this time, the B becomes a common point. Or I can use AC and BC. AC and BC. And that time now, the C is the common point. So if I ask one student, 3 different students, to show that the points are collinear, one student, student A, might use the vector AC and AB, show that them parallel and list A as a common point. Another student might use BC and AB and show that them parallel and list B as a common point. And a third student might use AC and BC and list C as a common point. Any one of them you choose to do, the result is the same. You have shown that you have parallel vectors with a common point. Parallel vectors with a common point. All right, we could put some mathematics to it now. All right, that's what you want to show. So you have 3 options. three options. And generally speaking, you don't have to do all three. The question will kind of lead you and let you know which two vectors to use. And sometimes you might have to decide on a vector, and you always use the easiest vector possible. Use the easiest vectors that will get you your answer. We're going to see that in some questions. All right, we're going to see that in some questions. Look at this example. Use a vectors method to show that the points A, the points M, 22, L, 30, and N, 06 are collinear. And then we have to find the ratio MN to LM. So basically, by them telling me to find this ratio, it means that I want to use a vector MN and a vector LM. Because the question says hence, you know. So it makes sense to use a vector MN and LM. And then what would happen is that my common point would be M. So I need to show that MN equals some value times LM first. That's what I need to show. So I need to find out what the vector Mn is and find what the vector Lm is, and then show that they are pairs. So let's look at it. Let's look at it. I'm going to use OM is that. If the point M is 22, then OM is 22 like that. The point L is 30, so OL is 30 like that. The point N is 06, so ON is 06. I'm going to find Mn now. Remember, Mn is O times the last minus O times the first. Look at it. O times the last minus O times the first. O times the last minus O times the first. Remember, guys, O times the last minus O times the first. So basically, then it is this one minus this one. So it's 2 minus the 3 is -1, and 2 minus the 0 is 2. 2 minus the 0 is 2. But understand that? That's my vector Lm. So I found this one first, Lm. I'm going to find Mn next. I'm going to find Mn next. So Mn now is On minus Om. See there? O times the last minus O times the first. Let's do that again. O times the last minus O times the first. So it's the On minus Om. So it's this one minus this one. So 0 minus 2 is -2, and 6 minus 2 is 4. But understand that? That's my Mn. But I can see that. And it's obvious, it's obvious that this one is equal to 2 times this one. But I can see that.
Yes, sir.
So therefore Mn
Yes, sir.
equals 2. So therefore Mn equals 2 times Ln. Mn equals 2 times Ln. Huh?
And sort of what is Wi-Fi disconnect over here now.
Start over this part. All right.
Yeah.
All right. So this question says we have to show that those 3 points are collinear. They give us the points M, L, and N, and they want us to show that the points are collinear. And then afterward, to show that the points are collinear, they want us to do this ratio, Mn to Lm. So naturally, since we're going to do the ratio Mn to Lm, I told you that you can use any 2 vectors from the 3 points. But because we have to show this, it makes sense to use these 2 vectors. And then the M would be the common point. The M would be the common point. So what we're going to do, we're going to find those 2 vectors, Lm and Mn, show that they are parallel, and then state that M is a common point. And that would mean that the points are collinear. All right, so let's go. So the first thing we're going to do is we're going to write down the position vector for each point, for this, this, and that. Write down the position vectors first. Because the question says use a vectors method, you know. So we're going to write down the position vectors for each, point. So first, the OM is 22. But understand why the OM is 22? Because if the point is 22, then OM, the position vector of M, is 22. If M is 22, right here, if M is 22, then OM has the same values, 22. All right, and then OL is 330, and ON is 06. Then I'm finding LM first, the vector LM, finding that first, LM. Remember, LM is O times the last minus O times the first. So it's O times the last minus O times the first. So it's OM minus OL. So it's this one That's OM minus this one, OL. What do you do now? 2 minus the 3, that's a -1, and 2 minus the 0, that's 2. So that's how we get the LM. Next thing we need to find now is the MN. MN. All right. So MN now is ON minus OM. Let's look at it again. O times the last minus O times the first. That's how we find a displacement vector. O times the last minus O times the first. Right? This one minus this one. So therefore it is ON, which is this one, minus OM, which is the first one. And therefore it is a 0 minus the 2 over here, so which is this -2, and 6 minus 2 down here, so which is 4. 6 minus 2 is 4. And that's what we have. And clearly you can see that this one is twice this one. So therefore MN is 2 times that. Sometimes you can see it, right? But the method that I used in the past was to factorize a large one. If I go by my method, I would multiply up this one and I would get 2LM equals -2,4. And because this is also -2,4, then I would equate these two. And you say that MN equals 2 times LM. That's the relationship. It's on the slide. So let's do it. So my old method, I would factorize a large one. And then now I would take this, because this is the -1, 2 that is also here. So take the LM and replace the -1, 2 right there. And I get MN equals 2 times the LM. That's in my old method. In any case, that's what we're gonna get. MN equals 2 times LM. Now, that what we have now, that means that the vectors are parallel. MN is parallel to LM. That's what that means, you know, because one is a multiple of the next. So it means that they're parallel, and also you have a common point M. So the two conditions are, one, you have parallel vectors with a common point M. And once you have those two things happening, it means that the points involved are collinear. It means that the points involved are collinear. That's what it means. Points are collinear. To get the ratio now, the next part is for us to get the ratio, this ratio. To get that ratio, what we have to do, take the modulus of both sides. Take the modulus of both sides of this equation now, this vector equation right here. Take the modulus of both sides. Right? See there? Take the modulus of both sides. So take the modulus of that side, of both sides, and you drop off the arrow. So you get the ratio of the lengths now. You get the relationship between the lengths. The length of MN is 2 times the length of LM. And you write as a ratio, as a fraction. You divide by the LM, write it like that. And then conclusion is that the ratio is 2 to 1. The ratio is 2 to 1. All right. Coming to the end of the notes part now, we're going to go into some practice and do some questions and see that this thing is really very easy. All right. There's one thing I wanted to show you though. Splitting, or I can say expanding a vector equation to find an unknown position vector. Now, this is just something extra that I want us to be able to do because of the nature of some questions sometimes. All right, that's what this is. This is just a skill that I want you to have, right? Because what happens is that sometimes you're doing a question and they give you a vector equation, but you need to find some position vectors. And it's based on the premise that PQ, for example, is equal to OQ minus OP. The point is, sometimes if you want to find this, you use these two. But sometimes you will know this and you want to find one of these. And so you will transpose, right? So if you know this and you know this, you can use equation to find that one here. If you know this and you know this, use equation to find that one here. And if you know these two, and use the two of them to find that one there. That's what this is all about. All right, so sometimes we have to split a vector equation to find an unknown position vector. All right, so I have an example up on the page here, right? This is just an example. So given the vector OP, so let's look at it. They give us the vector OP is that 4 small p. The vector OQ is 12 small q. And then they give us this vector equation. They give us that vector equation. PR is a quarter PQ. PR is a quarter PQ. And the question wants us to find OR, the vector OR. In terms of the small p and the small q, means that small p and small q must be in the answer when we finish. That's what it means. So I'm saying to find this OR, we have to split it out of this. Split up that vector equation, right? Write this as OR minus OP and make OR the subject. All right, let's look at it. Bam. So start with the equation that they gave us. And I want to split it into position vectors. I also will expand it into position vectors. Right? Split it or expand it into position vectors. Now that's what it is. What happened here? What happened here is that we write this in the expanded form, OR minus OP. And we also wrote this in the expanded form, which is OQ minus OP. Why would we do that? Because these are what we know. See? That's what we know. All right? And then we're going to expand. We're trying to make OR the subject because we're trying to find OR. You know? So we're going to transpose this over here and add it and leave OR as a subject because OR is the only one that we don't know. We know OP and we know OQ. Right? So we're going to come, so boom, and transpose the OQ. And at the same time, I'm expanding this quarter. So it's a quarter times this one, give me this, and a quarter times this one, give me that. And then now, this OP minus OP come over here, I'm gonna come plus OP. And now I know I have OR as my subject right there. Right, that's my subject right there, OR. All right, and then when I come to now, bam, put in the values. Because the small OQ up here, small OQ, the 12 OQ is 12 small OQ there. And then this OP, the OP is 4P. So this OP is 4P and this OP is 4P. All right, and that's what it is. All right, and then we work out all of this, you get the final value for OR. Final value for OR. All right, that's it. That's the notes. We just need to practice some questions now. Just need to practice some questions now, guys. All right, this one is good. Hold on a second. Hold on a second, guys. All right, guys. We're gonna put it all together now. I'm gonna practice some questions. Right? We're gonna practice some questions today. I'm gonna practice some questions on Wednesday. On Sunday, I'm gonna do more questions. And you're gonna do some work for yourself. All right. Everything that we have learned, you're gonna watch over the video. After we start doing the questions, you watch about the video, get about the information, and anything you're not connecting with, you will connect with. And that's the beauty about the online class that you actually know can actually watch the video again, recording again. All right. So what I'm gonna do now, I'm gonna let us do a couple questions, right? So what I'm gonna do now. Let's look like this. By the way, there are some must know items that are sent in the group. If you're looking at here, let me see. Show you. This first one right here is about midpoint. Right? It says midpoint determine the line AB. So this one's about position vector of the midpoint. That's what this is about. And also the displacement vector. Right? This is the displacement vector thing. Right? So if you want to find PQ, here, it's OP minus OQ. No, OQ minus OP. O time the last minus O time the first. Right? Using these two vectors right here. Make this wider so you can see. Right? That's what this is about. Right? There's some must know items and a couple of examples there for you to see. O time the last minus O time the first. So this is the O time the last minus O time the first. And then this now is a midpoint formula. Remember, it's an average. Remember, it's average. Right? So if you want to find the position vector of the midpoint of PQ is the average of the OP and the OQ. See it right there, but I can see it. Average. All right, OP plus, right? In here is a plus, right? Taking an average. So it's like a must know sheet. I want you to remember. Down here now is what we talk about parallel vectors. See here? If two vectors are parallel, one is a multiple of the next. See here? If two vectors are parallel, then this is our result. If two vectors are parallel, then one is a multiple of the next. That's it. Two vectors are parallel, then one is a multiple of the next. Example, I give you these two vectors. I want to show that they are parallel. What do we do? Get rid of any fractions first. What do I do to get rid of fractions with this one? Multiply it by 4. Multiply it by 4, I'm getting this. Multiply that one by 4. To get rid of fractions out of this one, what do I multiply it by 3? I multiply this one by 3, I get that. And then now, when the two of them equal the same thing, I don't have to multiply up anything. Two of them equal the same thing, then you equate these. Equate these, and that's when I equate them. See there? 4mn equals 3rs. That's what you have here. 4mn equals 3rs. All right? 4mn equals 3rs. And then once you have that, this means that they are parallel because you have expressed one vector as a multiple of the next vector. All right? Because remember, you know, I could also write this as mn equals 3 over 4 rs. Could write that as well. That option. All right? But it means that they are parallel. You get the ratio. All right, look here now. It says state two geometric relationship between m and n. Once I ask for two geometric relationship, one at this level is going to be that they are parallel. We have to show it by doing this. Another geometric relationship, the relationship of the length. So what do we do? Come right here. After we show that they are parallel and get that vector equation between them, then we take the modulus of both sides. We take the modulus of both sides, we get this equation here. With the arrows, it's a relationship of the length. It's a vector equation, that's a scalar equation. And then after you get that relationship with the length, then you can divide them. You can't divide vector, no. Okay? You can't divide two directions, you know, so you cannot divide these two. You can't divide them. You cannot divide the vectors because you cannot divide direction. That's why we have to take the modulus. That's why we have to take the modulus first and get out the direction. Take the modulus, get out the direction. This is talking now about the length of the vectors. Now that you have the length of the vectors represented there, then you can divide the length and write it as a ratio. Write it as a ratio. From that ratio, you can conclude that. So those are two relationships. See them there? Two geometric relationships. One relationship is talking about that they are parallel. Second relationship is about the length. All right? That's what I like to ask in CSEC. Look at this one now. This one is about collinear points. See here now? Collinear points. These are what I want you to study and remember. Use this to remember what we do. Use this must know sheet, study it, remember what we do. These are the main things that they'll ask you to do in CSEC. These are the main things that you must know to do. So use this as a reminder, as a revision of what to do. So I put a little question there and a little steps. So it reminds you of what to do. All right, so for the collinear points now, 3 points are collinear if you have two things. Parallel vector with a common point. Any one of those three you can use. And any one you use, what you will have is parallel vector with a common point. If you choose to use If you choose to use AB and AC, then A is a common point. If you choose to use AB and BC, then B is a common point. If you choose to use AC and BC, then C is a common point. You don't need to do all three, any one. That would mean that you have parallel vectors and you also have a common point. And you have to state a common point. Once you have parallel vectors with a common point, it means then that the vectors, points are on a straight line. The points are collinear. This is an example of how you can do it. Again, it's an example now. So you have this one, this vector, and this vector. And the question is to state one geometric relationship between the points. If the question asks for one geometric relationship between 3 points, the answer is that the 3 points are collinear, but you have to show it. You have to show it. You have to show it. How do we show it? Show that you have parallel vectors with a common point. You have to show that this vector and this vector parallel, and then now in this case, Q is going to be the common point, but you have to show it. What are the steps first to show that they are parallel? One, get rid of any fractions. So the first one, to get rid of fractions, I multiply it by 4. See there? Multiply it by 4. And that get rid of the fractions. The second one, to get rid of fractions out of this one, I multiply it by 3. Multiply it by 3. Good? That's what I do. In order to have the two of them equal the same vector, I can now equate these two here. So they equate those two there, because the two of them equal the same thing. And then now, what I have now are my parallel vectors. See there? I have this vector equation now. That means that the two vectors are parallel. See, PQ is parallel to QR. And the Q is a common point. See there? Q is a common point. Once you have these two things, parallel vectors and a common point, you can say, therefore, conclusion is that the 3 points are collinear. 3 points are collinear. So I wanted to use this as a must-know sheet. I set it up for you. Use this as a must-know sheet, guys. I sent it to you in the group to remind yourselves of the main thing that you need to do. There are other things you have to be able to do, you know. But these are the main things you need to remember how to do. All right, so let us go now and do a couple questions. All right, let's do a couple questions now. Let's do a couple questions. All right. Close this. Let's do a couple questions. All right. So this is from your handout, right? This is in your handout. So these are some questions in your handout. Just want us to do a couple ones. And what you will find is that the ones that they set, these are like some questions from long ago. All right. So for example, this one is 2002. Questions that they set in recent times are a lot easier. Right? They're a lot easier. All right. So I'm going to choose a question or two to do right here. All right, let me start with this one down here. Let me see which other one I'm mark. I'd mark a couple of them first. All right, let me start with this one down here. It's the easy one right here. Let's start with this one. Let's start with this one. All right, let's start with that one. Let's start with this one. All right, I'm going to do it over on this side of the page. All right, ready now. So they gave us those 3 points. Question gave us these 3 points. P, Q, and S. There are 3 points on the vertices of a triangle PQS. All right, those 3 points. And I want us to get the vector PQ and the vector PS. So first we're going to write the position vector of the points that they gave us. That's what we're going to do first. Write them as position vectors. So since they gave us the point P, 1, 5, this means that the vector OP is 1, 5. Not fraction, 1, 5. All right. And since they gave us, let me write them under each other. And so they gave us a point P15, gave us a point Q, which is 4, -1, and give us a point S, which is 6, 0. So since they gave us those points, it means that the vector OP has these same values, 1, 5. OQ, the vector OQ has the same values, 4, -1, and the vector OS has the same value as 6, 0. So those are your 3 vectors. First question wants us to find PQ and PS. PQ and PS. So we're going to write PQ and PS right there. Part 1. PQ. What is PQ equal to? PQ is equal to O times the last minus O times the first. O times the last minus O times the first. Last minus first. So it is equal to OQ minus OP. OQ minus OP. What is OQ? OQ is 4 minus 1. Here, this is OQ. Minus OP. OP is this one, 1, 5. 1, 5. This is the vector PQ. Notice I'm putting my arrow on top of all of them. Because I'm doing vectors. Arrow must go on top of all of them. All right, and then we're working this out now. 4 minus 1 is 3. This is 3. And minus 1 minus 5 is negative 6. Negative 6. So that is my PQ. And PS now. And PS. O times the last minus O times the first is OS minus OP. O times the last, which is that, minus O times the first, which is that. O times the last minus O times the first. So this therefore is equal to OS. OS is this one, 6, 0, minus OP is this one. OP is 1, 5. Now I wrote that out, which is 6, 0. 6 minus 1 is 5. 0 minus 5 is negative 5. So that's my PS. So I have found my PQ and I found my PS in part 1. So far so good?
Yes, sir.
Yes, sir.
So far so good, guys?
Yes,
Yes, sir.
yes, sir.
Yes, sir.
Are they good? Answer me now. Let me know. So
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. We go, man. We go.
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Oh. All right, very good. Very good?
Yes, sir.
Yes, sir.
All right,
Yes,
beautiful.
sir.
All right, cool. All right, let me just write down what OP is over here. So OP is 1, 5. OQ is 4 minus 1. And OS is 6, 0. All right, next part now says determine the position vector of OG and OH. G and H are midpoints of PQ and PS. See that? That's what they're saying. So let's write it down. Let's write down what I'm saying in part 2. Part 2. So part 2 says G is midpoint of PQ, right? See that? Therefore, OG is half OP plus OQ. Average. Position vector of G, which is a midpoint, is half OP plus OQ, like an average point. But understand that?
Yes, sir.
But understand that?
Yes,
Yes,
sir.
sir.
All right, good. So we're gonna work it out now. So it becomes half of OP is 1, 5 plus OQ is 4, negative 1. I'm taking half of that. So it becomes half of 1 and 4 is 5. 5 minus 1 is 4. But understand that?
Yes, sir.
Yes, sir.
Yes, sir.
Half of that, they get 2.52.
Sir.
2.52. Because OG is 2.52. That's OG that I found. That's what the question asks for, OG. So I found OG. See, it asks for position vector OG over here. Now we want OH. OH is the midpoint of PS. So let's do that OH down here. So now. So OH, let's do it now. OH.
Sir, no, sir.
Huh?
Sir, I was saying when you add OP plus OQ, whenever, in the question before, whenever find PQ already.
PQ? No. But OG is not. PQ is different, you know. PQ is OQ minus OP. The midpoint, the position vector of the midpoint is not half PQ, you know. That's what I was telling you. That half of PQ we want. Portion vector for the midpoint, like an average, is the average of the OP and the OQ. That's what it is. Average of the OP and the OQ. So you have to remember, it's not half PQ. That's a common mistake a lot of people make. Understand? We don't have,
Yes,
we
sir.
don't, right. So this is not PQ, you know. This in here is not PQ. This is OP plus OQ, average. So remember, we have to take, to get the position vector of the midpoint, we have to take the average of the position vectors of the two endpoints. Let's look at the next one. Let's look at the next one. H, the next one. H is midpoint of PS. Therefore, OH, portion vector H, is the average of the P and the S. Average of the OP and the OS. That's how you do it. Average of the OP and the OS. So I wrote them over here. That's why I wrote them over here now. So it becomes half of OP is what? OP is 1.5 plus OS is 6.0. And averaging that, so it becomes half of 7.5. Half of 7.5. Half of 7.5 is 3.5, 2.5. So this is OH. 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 That's portion vector of H. Good?
Yes, sir.
Yes, sir.
All right. So we have answered that part now. Look at this part now. Part 3 says now. Part 3 says now, determine GH and QS. GH and QS. Determine GH and QS. Watch this now. I'm gonna do GH first. Part 3. We want GH now. GH. The GH equal. GH is OH minus OG. That's for GH, you know. O time the last minus O time the first. Now I can use this because I know that I know OH and I also know OG. That's why I'm using that formula. O time the last minus O time the first. So it's equal to the OH is what we just found a while ago. 3.5, 2.5. See here, we just found it a while ago. And the OG what we found before. Where is the OG? That's the OG 2.52. 2.52. So you minus 2.52. And then subtract them to get the GH. GH. So you get 3.5 minus 2.5 is 1. And 2.5 minus 2 is 0.5. So this is 0.5. So that is GH. Next thing I want to find now is QS, what on the right side. Yeah?
You have to put the 0 point.
Huh?
You have to put the 0 in front of the 0.5, sir.
Yes, man.
Okay.
Do math properly, man. Don't put no 0.5 like that. Put 0.5. Good question.
Okay,
Do the proper way. All right. Next you want is QS. So can I say and QS again equals OS. OS, right? Properly. OS minus OQ. O time the last minus O time the first. Everybody getting that? No. That's what vector is easy, you know. O time the last minus O time the first. What is OS? OS over here, 6.0. 6.0 minus OQ is this one, 4, -1. 4, -1. Work it out. That becomes 2, 1. That is QS. QS. Look at the last part now. Hence, you know, part 4. State two geometric relationship between GS and QS. So to do that, what they want us to do is use this GH and this QS to state two relationships between the lines. What are going to be the two relationships? Before we even do it, tell me what are going to be the two relationships. What's going to be the first relationship between them?
Sir, then parallel.
Yes. What's it going to be the second one? What's the second one looking for? What's the second geometric relationship we're looking for? If question says state 2, what's going to be the second one we're going to look for? One, we're going to look for them
Sir,
being
then
parallel.
uncommon.
No, man.
Cut them card.
Geometric. Listen, geometric has to do with parallel, perpendicular, the relationship of the lengths. If the question asks for two geometric relationship between two lines, one will be that they are parallel, and the second one will be how much longer one is more than the next one. I can express the length as a ratio. So one geometric relationship is going to be that they are parallel, and the second geometric relationship between two lines that I want you to always look out for is how long one is more than the next one, or you can use the ratio of the length. So we are now comparing this vector and this vector.
Sir,
So that
Q
they are
is 2
parallel.
times longer than GH.
QS is 2 times the length of GH, but you have to show it. You cannot just state it. I don't want you to just state it. I want you to actually do it. So even though this question says state, I don't want us to do it that way. I want us to get into the habit of showing it. Because most questions will say, show two geometric relationship between them. It's a difference. So we're going to show it now. Watch this now. I'm going to show it down here. So I'm going to show it down here now for part 4. Let's do it down here and show you how you have to do it step by step. So part 4. So I have the two vectors I'm going to use. QS and, no, not QS, I'm first. Let's do it. GH, don't matter still. GH and QS. I want to show two geometric relationship between those two lines. So I'm going to use the two vectors to do it. GH first. Let's write them down again. GH, we worked it out a while ago. It is 1, 0.5. 1, 0.5. And I am using QS as well. And QS is 2, 1. What are the steps to show that they are parallel? Tell me, what are the 3 steps? That's the first thing we do to show that they are parallel. What's the first step? Don't remember.
Sir, you take out the fractions.
Get rid of any fractions. Get rid of any fractions. That's the first thing you do. Get rid of any fractions. So are there any fractions in these two vectors?
No, sir.
Sir, point.
0.5 is a vector. 0.5 is a fraction. What do we do to get rid of 0.5 as a fraction? What do we do?
Times it by 2.
Times it by 2. So I'm going to times this one by 2. Because we don't want the fraction. Times that one by 2. Right? It's obvious that one is twice the next, but I'm still talking you through the process, talking you through the steps. So when the value is not so obvious, you still know what to do. That's why I'm talking you through the steps, you know. So even though this one is very obvious that the one is 2 times a 1 there, I'm still talking you through the steps. So when the values are not so obvious, you will still know the process. Good? So when I multiply that 1 by 2, remember I multiply this side by 2 as well. So I'm going to get 2GH now equal to 2, 1. This times 2 is 2, and 0.5 times 2 is 1. And I now have them equal. See, they are now already equal. See, them already equal. So when they are equal, what do you do next? You don't have to multiply up the last, so the second step missing now. So what do you do next? What's the last step?
Equate and simplify.
Equate, good, equate. Sometimes after equate, you have to simplify. Just equate and good enough. Sometimes you have to equate and simplify, sometimes you have to simplify. So since the two of them equal, I can now write that QS is 2 times GH. See? That one here equal that one there. See that? Because the two of them equal to 2, 1. So therefore the left side and the two of them equal. See that? So what does this statement mean now? This statement that we have here, this statement means that therefore QS is parallel to GH. That's what it means. All right? And if we take the modulus now, that's the first relationship we wrote in. That's relationship number 1. Second relationship now, we're going to give them the length. So what we'll do, take the modulus of both sides. So we're going to take modulus of both sides now. Take modulus. Take modulus of both sides. you're gonna get the modulus of QS equals the modulus of 2 times GH. And you drop off the arrows. So you get QS equals 2GH. That knows a scalar relationship. So you can write the second conclusion now. Relationship number 2. See it here? Second conclusion. Length of QS is 2 times or twice length of GH. This is your relationship number 2. 2 geometric relationships. That's it. If we want to, we could instead write this as a ratio. We could instead write this as a ratio. Let's use a blue for this. So for this, we could continue and say, or instead of stating this, we have instead written it as a ratio and do QS to GH is 2. 2 is the same as 2 over 1. See, I divide another GH. It's 2 over 1. Therefore, QS to GH to GH equals 2 to 1. That's a geometric relationship as well. So I could have used this as my second geometric relationship between the ratio of the length of the lines. 2 to 1. All right, so that's a vector equation. We could do some nicer ones now. We could jump up and do some other ones. All right, let's do some other ones. Let's do a nicer one up here now. Let's do some real maths now. We're doing a real one yet, and we'll do a real one now. Let's do this one right over here. So let's have some fun with this one. Let's do this one. So it's another lot of parts on it. All right, let's do this one. Good. Okay, let's do it over here as well. Okay. Ready?
Yes, sir.
All right, so that one gave us that diagram. In fact, maybe what I can do is just draw the diagram, same place and there. That's what it says. So give us a vector diagram. Now remember, when you have a vector diagram working with, you can just look at the diagram and see how you go from point to point. It's easier when you have a vector diagram looking at, because you can see how you go from point to point. All right, let's see what them say now. Question says, OQ and OM are position vectors such that OK is small k and OM is small m. And so then put them on the diagram here. OM is this small m right here. So, and OK, this vector OK is this small k right here. All right. So in other words, to go from O to M, to go from O to M, you use this small vector M, and to go from O to K, you use this small vector K. All right. So those are your displacement vectors. They're representing them with letters now instead of with numbers. All right. Question says, sketch the diagram above, and then they want us to show the appropriate position of the points R and S such that, whatever them say now, R is the midpoint of OK. So if R is the midpoint of OK, then it means that R is somewhere around here in the middle. See that? R is in the middle right there. But I get that. So I can put R right here.
Yes, sir.
Now if R is right there, let's rebrand it with the vectors now. If the whole vector is K and R is in the middle, then what is the vector from O to R? What is the vector from O to R? If the whole thing is K and R is in the middle, what is the
Half,
vector
sir.
from O to half K? Don't say half K. So the vector from O to R is simply half of K. And the vector from R to K is what? Up here. This half is what? What will be this half up the top? From R to K is what? From
sir.
big R, half K does the same. The whole thing on K, and you cut it in a half right there. So then almost half K and half K this now. half and half. You break it half and half. So the top half here is half K as well. Up here is half K. I'm breaking on the diagram for you. So underline the small k. See? Underline the small m, underline the small k. So far, so good? Let's look at this one now. The next part now says that S is on OM, such that OS is 1/3 of OM. OS is 1/3 of OM. So relatively now to this line, where would the S be? OS, O to S is 1/3 of O to M. So OS is 1/3 of the O line. What do I do to position S on this diagram? What do you think I should do? What do you think I should do to find the position S? 1/3. How do I get 1/3 of something? Divide it into 3 equal parts, like so and so, don't it? See that?
Yes, sir.
Don't it? And therefore S is right here. S is right here. See that?
Yes,
But
sir.
see that? Good. I'm going to put on the vectors now. So if S is right there, the whole thing is M. What is the vector from O to S on the diagram? Should you know this thing easy?
1/3.
1/3 M, don't it? 1/3 M. And the remaining vector to finish this line out here, the whole other vector out here. So from S to M is what?
2/3.
S, 2/3 M. Beautiful. 2/3 M. So that's 1/3 small m and 2/3 small m. As easy as I wonder if I can cover up these things. Let me see if I can cover up on this. On the white. We can cover up the right thing that I have here. See if we can cover this up. See if we can cover this up. I try to cover that up. We can cover it. I'll shade it out. And we can shade it out. I'm gonna shade it out. Shade out this thing. So we can cover it. Try to use this. Cover up that. All right. Cover up this thing. All right. But I see that now. So I'm covering up those things. All right. I don't want us those to mess us up, right? I'm covering up those right now. So we can see what we have left. I'm use a black now and draw a line. Draw a black line now. Through here. Good. All right, let's work with that. All right, so that's what we have so far, guys. But understand that so far, the more information we can put on the diagram, the easier. You know, I just know we can know how we go from point to point. You know, it's very easy. Vectors is just about how you go from point to point for the most part. So we have placed the point S and the point R on the diagram based on what they said. All right, and then based on those positions, now we know that the line OK break down into half K, and the line OM break down into 1/3 M, 2/3 M. This is 2/3 M. Let's write it better. 2/3 M, 2/3 M, right? 2/3 M, 2/3 M. All right. So ready now. Let's answer the questions now. Now they want us to. That's how we do the diagram. So we just finish this part now. So this part is the diagram that we just did there. All right. In the exam that you're doing, you basically have to just draw it on the diagram. So we're going to answer these over here now. Look how it easy now. We're going to answer these now. Watch this now. Look how it easy now. Watch this now. First part now wants us to find MK. B part 1. We want us to find the vector MK. Now, since you have a diagram, we just need to look at the diagram and see how we go from M to K. Look at the diagram. How would you go from M to K? Going along the vector direction that you know. Let me use a different color so you can see. Let's use the blue. From M to K. To go from M to K, you just come back here, so, and go up there, so. So come back this way and go up, so don't it? See that?
Yes, sir.
So that will be minus M plus K. See that?
Yes, sir.
Minus M plus K. But we could also use position vectors and do it. We could also say MK is OK minus OM. Why can I do this? Why can I do it this way? Why?
Sir, because
Because I know them. See here, I know them. Yeah, because I know them. So this therefore is simply equal to K minus M. So MK equal that. Done. First part done. It's done. Second part now is RM. Got the diagram now. RM part 2. Got the diagram. How do I go from R to M? Look at the diagram. From R to M. R to M. R to M. What do I do to go from R to M? Talk to me. Go from R to M. What can
So
I do?
you go from R to O, then you go to your right to M.
Beautiful. So let's write it out. Beautiful. I like how you say it. You even said good. I can go from R to O, and then I go from O to M. And the R to O is what? Talk to me. What is R to O?
Half K.
Nope. Come again. You almost have it. You see, you miss out one thing. R to O is the opposite direction. So it's minus half K. See that?
Yes, sir.
Good. So I hope you're learning, you know. So you're going the opposite direction. So it's minus half K. Beautiful. Minus half K. And the OM is what? What is OM? OM is just M. See there? That's it, you know. That is the vector RM, you know. Done. That's the vector RM. See that?
Yes, sir.
Beautiful. As easy as that, you know. Next one we want, so we'll finish this one now. Next one we want is KS, part 3, KS. Very easy topic, this KS. Look at the diagram again. How do you go from K to S now? It's K here. Yeah, try come here, so talk to me. Say it already said a while ago. Where you go first? K to what first?
So you go from K to O, sir, then you go
K to O, and then O to S. Talk to me now. What is K to O? What is K to O? Remember the whole thing come up here, so was K, you know, at the beginning. No? Don't forget that.
negative K, sir.
Beautiful. Negative K. So that's minus small k. And the OS is what?
1/3 M.
Beautiful. 1/3 M. Done. That's it. That is a KS. Okay, you know, the question said in terms of K and M, you know. You say you just want all the answer them in terms of K and M. See there? That's what in terms of K and M mean, you know. You have to write the answer them in terms of K and M. All the answers must be something with the K and the M in it. So finish them 3 there now. It's an easy. Next part now. RS now. RS part 4. Go on. RS. Talk to me now. What the diagram say now? RS. Where are they? So R here. And say S there. Someone come down here. So now. Talk to me. Say it to me again now. I'll go from R to S. Talk to me again.
So you go from R to O, sir.
R
Then
to
you go
O. And then
O to S.
O to S. Beautiful. O to S. Where the R to O equal to?
Negative half K.
Negative half K. And then where the OS equal?
1/3 M.
1/3 M. So vectors easy. Done. So we're done that part there now. Sweet. Soft. See that? Easy like that. All right. So far so good, right? So far so good.
Yes,
What's the
sir.
last? All right. But good so far?
Yes, sir.
Yes, sir.
All right. All right. Beautiful. Let's look at this last part now. Last part now says L is the midpoint of RM. L is the midpoint of RM. L is the midpoint of RM. So I'm going to draw it in and show it on the diagram, right? L is the midpoint of RM. So I'm going to draw it in. So say RM here. L is the midpoint. So let me say L right so. That is the point L. All right. So L is right there. All right. What is now? Question says, pay attention now, you know. Question says, prove that RS is parallel to KL. Prove that RS is parallel to KL. Let me draw them on the diagram and show you. So what I'm gonna say is that a line here and a line here. Parallel. And you can see from the diagram, so them parallel too. So the question is saying, show us them parallel, draw them broken. Show us a line here and a line here. Parallel. Show that them parallel. We're going to show that them parallel. What we have to do to show that them parallel? What we have to do to show that two vectors are parallel? What do we have to do? What do we show that two vectors are parallel?
You have to get rid of the fraction.
No, man. What is the final outcome I want? I know that is the steps. What's the final outcome when two vectors are parallel? RS and KL. What is the final outcome?
You have to have a similar point here on a street.
No, man. That's collinear points. All right. Yes, you know, man, I love when I make the mistake them, you know, so we can correct it, and then we learn from the mistakes, you know. So the common point this is when you have collinear points. This is no collinear now. This is parallel vectors. So let me say it again. To show that vectors are parallel, I have to show that one of them equal a multiple of the next one. So for example, we need to compare the two vectors and show, so for example, RS equals some number times KL. That's what I need to do to show that they are parallel. I'm going to work out what that number there is. You understand? That's how you show that they are parallel. If you can establish an equation like that, it means that they are parallel. So if I'm going to show that they are parallel, I need to know the two vectors. I need to know RS. Do we know RS already? Sometimes you have it already. You know, see that we know RS already. Bam. What we don't know yet is KL. We don't know KL yet. We don't know this one yet. So I've got to find it. You see that? You understand me? And then after I find the KL, I may have the RS. I have to show so one is a multiple of the next. Going through the 3 steps. Going through the 3 steps. What are the 3 steps? Get rid of any fraction. Multiply up the small one to equal the large one and then equate. And when you do that, you'll get one of them equals some number times the next one. All right. Enough talking. I could do it. Enough talking. I could do it. I know someone well wants to do it. So what we're going to do is show that them parallel. We can start it from right here. So we're doing part 4 now. Part 4. Part C. So we're comparing RS and KL. That's what we're doing. Comparing RS and KL. I can write down RS from now. RS, we know it already. It is minus half K plus a third M. That is what RS is. I need to find KL. So I can say no. Let's do it down here. So I can say no. Talk to me now. KL. Look at the diagram and tell me how we go from K to L now. Look at the diagram and tell me how we go from K to L. What do we go from K to L? I'm going to show you something now. You pay attention. Let me tell you before we start. Now, usually, how these questions go is that the parts up here that we found will help you with the part down here. That's how the questions usually write. So when you find one thing, it helps you. Sometimes when you find one thing, it helps you find the second thing. It helps you find the third thing. It helps you find the fourth thing. It helps you find the fifth thing. It's usually like a chain reaction. That's how vectors go. That's how these questions write. Now look at the RL and the diagram. Look, let me just point it out to you. This is the first time you're doing this. I'm going to tell you. Look at the diagram. So right now, you see the RL. The diagram, you know. Right now. Yeah, let's use a green. This RL right here is half of RM. Can you see that? Can you see that RL is half of RM?
Yes, sir.
Can you see that? Well, guess what? We know RM already. See RM here. We found RM over this side already. So RL is just half of RM, you know. See that? And tell me now, how do we go from K to L? Look at the diagram. It's the easiest route to go from K to L. See, I want to write it down. So tell me. K to L. K to L equals what? Break it down for me. Look at the diagram. To go from K to L. Talk to me. Where would I go first? Remember, I know it's just how you go from point to point. Look at it. How do I go from K to L, traveling along the vector direction that I know? even in the opposite direction to the one that I know. Look at the diagram and tell me, guys, I want to go from K to L. Tell me now, man, tell me the letters, the points.
Sir, I go to K to R.
K to R, beautiful. K to R, and then
Half RM.
half RM. Let's write over first. We go K to R, and then we'll do R to L, don't it? But R to L is really half of RM, don't it? See
Yes,
that?
sir.
So, but all right, I'm gonna write it over here so we can need the space. All right, let's go again. So we can say now the KL that we want, we need the KL to use it up here, so you know, to do the comparison. So we need to find the KL. The KL based on the diagram is K to R and then R to L. But we do have to waste time trying to work out the R to L because the R to L is simply half of something that we know already. Right? And that's how it do. Because we already know RM, we found RM already, you know, see down here, so we worked out already. Let me write it what it is. Let me write what it is down here. We worked out RM already. Let me write it out. Let me write out the RM down here. So we can have it to look at. Write it in blue. So we worked out the RM already. Let me write it back over here. See here, we worked out the RM already. See here. It was minus half K plus M. See that? Minus half K plus M. So come back down here, so now we are trying to find it. So instead of RL, we're going to write half RM. So we're going to write the KR plus half RM. It's easier to use half RM instead of RL. Good? And let's put in the values now. Let's put in the values now. What is KR equal to? What is KR equal to?
Negative half K.
Negative half K. Let's write something here. So RM is minus half K plus M. Let's write it here as well. Right, the RM so. The RM is equal to this, right? And so now tell me. I'll put it right there so you can see it. Right, so we get negative half K based on the diagram. K to R is negative half K. And then now I'm going to write the half RM. This color half of this. See that? Half RM is just half of this, you know. Right? So it's going to be what? What is going to be? What do I write? Half of this is what? Let me write it out for you. Let me write it out for you. Plus half of minus half K plus M. Good? Let me write it out for you. So it becomes minus half K minus a quarter K plus half M plus half M. See that?
Yes, sir.
But see that? But it's when we get this part here, so.
Yes, sir.
Right, because it's a half times minus half, give me minus a quarter. And then half times the M, give me half M. Now, let me tell you something now about vectors now. You don't want to have multiple of the same components in your expression. You just want to have one K value and one M value. So I need to put these two K values together and get one K value in the equation. But understand that. I don't want to have two expressions with a K in it. I put those two K values and get one K value. So watch this now. You see this half right here is same as a quarter. So let me write it. Let me write it for you. Let me not cut out any steps. So I'm going to make these two terms of the same denominator of 4. So I'm going to write this as minus, not a quarter, 2 over 4, minus 2 over 4 K minus 1 over 4 K plus half M. Anybody understand why I put this as 2 over 4 instead of half? Why did I do that?
Sir.
Anybody can tell me why I did it? Because I want these two fractions to have the same denominator. As when they have the same denominator, I can just add the numerator values and put by the common denominator. So it becomes minus 3 over 4k. That's where these two come. Minus 3, minus 2, and minus 1 is minus 3. And 2 of them over 4, 2 of them over 4. And then we have a plus half m. So that is my KL. That's my KL right there. All right, that's my KL. So let me go back to the comparison now. So we have KL and we have my RS. So what I'm going to do, so I'm comparing these two vectors now, comparing this vector, RS, and I'm comparing this vector, KL. What do I do now to compare them? Let me write them over again. Let me write them over again. So let me use a different color now. We're going to do the final thing. So now we have this, because I'm doing the first one and I'm taking my time. Right? Because now I'm going to finish already. I'm just taking my time so I can get it. Now we have the RS, which is, what is the RS? The RS is minus half K plus a third M. Minus half K plus a third M, and the KL is minus 3 over 4K plus half M. All right. So we have those two vectors now to show that they're parallel. See, question says show that they're parallel, RS and KL. That's what we're doing down here now. All we did so far, we had to work out KL. We never know it, so we had to work it out. So that's what I did first up here. Up here was just to work out the KL that we don't know. Good? So that's what all that work was about. Now that we know KL and we have the two vectors now, we have the RS and the KL, we want to show that they are parallel. 3 steps. Talk to me. What's the first step?
Remove any fraction.
Get rid of fractions. How do I get rid of the fractions out of this? What do I have to multiply by to get rid of all the fractions one time? What number can I multiply by? 6. Beautiful. If I multiply this by 6, all the fraction gone. If I multiply it by 6, I'm going to get 6RS equal. If I multiply this half by 6, it becomes 3. So I get negative 3K. If I multiply this by 6, it becomes 2. So I get plus 2M. Good? This one now. This one now. What do I multiply this one by now to get rid of fractions? Get rid of all fractions. What do I multiply it by to get rid of the fractions?
4.
4. Beautiful. Multiply this one by 4. All fractions gone. I want to look, it's very difficult with them number a half and 1/3 and 3/4 and half to know the relationship between these two. It's difficult. That is why we have to get rid of the fractions first. You understand why we have to get rid of the fractions now?
Yes, sir.
Look at the half and the 1/3 and the 3/4 and the half and all. It's difficult to see the relationship. So to make it easier for us to see the relationship, we get rid of the fractions. Multiply them out by a constant to get rid of the fractions first. So this second one, we'll multiply it by 4 to get rid of all the fractions. It's going to become 4KL equals minus 3K plus 2M. See that? How will you notice now when you do that? What do you notice? What do you notice?
Sir, they're equal.
Them equal already. Beautiful, them equal. So because the two of them equal, this two of them equal the same thing. It means that something here equal as something there. You see that? So know that them equal. What do we do next? What's the next step? What we call it? What's the third step in the procedure?
Sir, equate.
Equate. And if we can simplify, we simplify. So because them equal, we can now equate. So when we equate, we're going to get 6RS equals 4KL. Done. That means that them parallel, See there? We can simplify what we want and write 3RS equals 2KL. We divide 2 by 2. Or we can write RS equals 2 over 3 over 3 KL. That means that them parallel, because one is a multiple of the next. But don't say we never have to do this, we never have to go no further. Because we already know that one is a multiple of the next. So them parallel, so this means that them parallel. Right? But if you wanted to simplify it down to that, you could do that. And then write a conclusion. Write a conclusion that implies that KL, no, RS, no matter which one you name first still, that implies that RS is parallel to KL. That's what it means, because one is a multiple of the next. So the two lines parallel. And even on this diagram that we drew, you can see that the two lines parallel. See there? Two lines parallel, a line here and a line here. Parallel. You can see it on the diagram. I'm going in the same direction. Nobody see that?
Yes, sir.
I wanted to work the question over again by yourself, guys. I wanted to work the question over again. See, that is nothing to it. The only reason why it look like it takes so long is because I'm explaining what I'm doing. I'm explaining, but you see that is very easy. Come on, we could do one more. What time is it now? More maths equals better maths. 5:30. We could shot one more before we finish. We could shot another one. More maths equals better maths every time. I want you to go and work the question over again. All right? I'm going to choose an easy one. I'll finish off the day. I'm going to do this one right here. So let's do this one right here. Let's do this one. This one right here. This one is from 2006. All right? This one we're doing that with a tick. All right? We're doing this one now. We're doing this one, guys. All right? On Wednesday, we're going to practice some more. Not good no, and not going to give you anything to do for yourself yet, you know. I will do them first, then you do them afterwards. I do them, explain them, record the video, you go and you work them back over by yourself. And then eventually you see that you're improving and getting better. And then after I do a number of them that you do after me, then I will go and give you one to do for yourself. And then we'll go into revision mode. All right, and you get questions to do for yourself. But the important thing, guys, that you have to work the questions by yourself. Do them after I do them. You have the video to look back. So you play the video, you pause, you work, you pause, you go back and you say, oh, sir, do this again. Ah, that's sir, do. Go back, you work and you work and you work. I don't remember what sir do. So sir, this about this again. You go back and you listen again and you say, oh, all right. And you go, that is how you do it. Because we're learning, we're still in a learning phase. You have to work through the learning phase, guys. That is how we improve. And then we get better and better and better and better. It is called progress before perfection. We just need to make mini progress each day. Each time we do a question, we make a little more progress, a little more progress, a little more progress, a little more progress. And then eventually we can do the thing perfectly. We make a look at mistakes and we learn from our mistakes. But you have to do the work. I am making it easy for you by doing the questions first and explaining it to you. So you don't have to go and struggle on it. You don't have to go and struggle on them by yourself. Because I'm doing it, explaining it. You go and do it after I do it. Use what I did as a guide. Because the video is there and the solution is there. Use it as a guide to know what to do and you learn from your mistake. Try it like you tried it by yourself, you know. But if you're stuck somewhere and not remember, you look back at the video. And you come in the classroom, the students would have write out the solution and then would have to look back on the solution. Now you have video. You look back at the video and you hear what I said or I explained it. If you never remember what I said, you listen back the video. So you play and pause the video. Play, pause, rewind, play, pause, rewind. And you keep doing that until you finish the question. Go on the next one. Right? Sometimes you might have to, all right, use my video to help, and you do it, and you go and you do, and you do it over by yourself fully. And you don't need my video. You just work it over by yourself fully. So use the video the first time, maybe use the video the second time, and the third time, no, you just do it the same question over by yourself. When you can do the question by yourself, they say, yes, ready for the next question now. It's a work in progress. You have a lot of help. Use the help that you have. All right. So let me start talking now. I'm like talk. So I could go into this next question now. So this question gives us this diagram. It said the diagram below shows the position vector of 2 points, A and C. So them here, this is A and this is C. C is on the y-axis, all right? C is on the y-axis. And clearly A is the point 62, that's the point 62. And this point is 0, 4, 0, 4. So we can write them as position vectors, all right? Question says, boom, boom, boom. It said, look what it said now. It said, complete the diagram to show. So they want us to draw something on this diagram. They want us to draw something on this diagram. Use a thicker pen. Complete the diagram to show the point B such that OABC is a parallelogram. Now listen now. I must explain something here now. It's a parallelogram. Remember, a parallelogram has two pairs of equal opposite parallel sides, you know. As a parallelogram, you know. They like to give parallelograms in vectors. All right. So the thing about it though is that the letters O, A, B, C must go around the object in the same direction. So see here, O, A, B. B must be somewhere up here. So C. So you're going around the object in one direction. O, A, B, C must go around the object in one direction. But understand that? So you can't go and put B. Well, B has to be somewhere up here. But it's a parallelogram. So it's very easy. It's very easy. So since this side is how many? 4 units up, B is going to be 4 units up on this side. 1, 2, 3, 4. So B is going to be right there. But understand that? Because a parallelogram. Good. So B is going to be right there that I have marked. That's where B is. I want us to draw it. So let's go like that. The ruler. And then go like that. With the ruler. And that's your parallelogram. Easy like that. Good. Simple as that. So that's where B. So let's write down some points. Let's write down some points. Based on the diagram that we have drawn, right? A is a point. What is it? 6, 2? 6, 2. B is a point. What we'll get for the point B. B is a point 6, 6. 6, 6. C is a point. C is a point. C is a point 0, 4. 0, 4. But I get that. Those are your points, A, B, and C. So based on that, it means that OA, if we need it, is 6, 2. OB, if we need it, is 6, 6. And OC, if we need it, is 0, 4. 0, 4. OC, if we need it, is 0, 4. All right. That's what I want us to do now. So we'll put in the point. So and finish that part already now. So put in the point and draw the parallelogram. So that part done. Make a tick it. This part done. Next part it says the vector U. See here, everybody can see it. The vector U. We must show the vector U where U now is equal to OA plus OC. Remember, you add the vectors nose to tail. OA plus OC. So what we can do? We can make calculation help you now. But watch this now. OA plus OC is like you take this vector OC here. I'll show you. It's like you take this vector OC and you move the tail and put it over here. So, and therefore to have this just the same. Another way you can look at it is that this vector which is OC, this vector is also OC. This vector is also OC, you know. So AB and OC is the same vector because they're equal and parallel. So therefore, use a different color now. Blue. This is OA plus OC. That's OA plus OC. OA plus OC, and that is the vector U up there, so that's what they want. That is the U. OA plus OC. Well, look how the vector is wicked now. Look how the vector is nice now. Not wicked, nice. Look how the vector is nice now. I can calculate it. So the diagram show me that. Diagram just show me, you know, that my answer is this vector up here, you know. Straight up there, so you know, that is the U, you know. But look what the calculation going to give me now. So that U would be equal to 6, 6. This is what I call 6, 6, right? Which is same OB, right? 6, 6. Look how the calculation we can show me now. So it's really 6, 6 is the answer. So I'm doing part 2 over here now. But I'm doing by calculation, part 2. Them tell me say U is OA. U is OA plus OC. OA is 6, 2 and OC is 0, 4. If I add them, I get 6, 6. 6, 6. That is U, you know. So see, use the vector 6, 6. See? Must use the vector 6, 6. But guess what the thing about it now? Since this start at O, the U must also start at O. Because remember, guys, that this vector equation right here, it means O to A and then O to C. But remember that this OC is this OC, so you have to move the tail of this over to here and put it there. So the resultant is that, as I just explained, right? We better understand that. So at the end of the day, the vector that they want U and they want us to show it is the vector from O to B. Right? The vector from O to B. This vector from O to B. That vector is U. U. And it's the same vector OB. Good? How is stay?
It's good, man, sir.
Yes, sir.
All right, good. So that is the vector. So we answer part 2 now. We take it off. Part 2 done. Part 2 done. Bam. So we show it. Next part now. Write as column vectors now in the form. They want us to write OA. We work it right already. See there? OA is this 6, 6. I have to answer it on part B. Right already, you know. OA is 6, not 6, 6, 6, 2. 6, 2. Right, that's the first part. Next thing I want OC. OC is 0, 4. So I say I give 3 marks. 3 marks at, you know. To write those, you know. What them want next? AC. Diagram can tell us AC, you know. Watch this now. AC. What diagram can tell us AC? These are different color. I'll show you. Diagram tell me AC. AC. Watch this. How many units left? All right. 1, 2, 3, 4, 5, 6. That's negative 6. 1, 2, 2. So the answer for this is negative 6, 2. Negative 6, 2. Better. Negative 6, 2. The diagram tells me is negative 6, 2. Remember, vectors is where you go from one point to another. Look at it. Go from A to C. I got 6 units left. 1, 2, 3, 4, 5, 6. And then 2 units up. 1, 2. The diagram tells me that the answer is 6, 2. But I can also calculate it. Look how I calculate it now. Bad and easy now. Wicked and bad and easy now. Watch it now. Part 3. AC. OC equal. AC equal. O times the last minus O times the first. Remember the answer now. See the answer here now. It's the answer now, guys. Remember. This right here is the answer. I know the answer before I even do it. Alright. Use the diagram and get the answer. OC is 0, 4. OC is 0, 4. Minus OA is 6, 6. See it? 0 minus 6 is negative 6. 4 is AC, them say. So I'm gonna get negative. OC. So when I get the right answer, let them say AC. A to C minus 6, 2. So I'm gonna get that. Something is wrong. Something is wrong. 6, 2. So man, it's a 6, 2, man, not 6, 6. It's a 6, 2. 6, 2. AC is 6, 2, not 6, 6, 6, 2. See? OA, sorry, OA is 6, 2. 6, 2. So 0 minus 6, this is 4. This is 4. 4 minus 2 is 2. So that's it. That proves it. That is AC. That is AC. So that's it. All right. So I can get it from calculation. I can get it from the diagram. So that's what I tell you. The diagram and the calculation can give you the same answer. All right. And whatever you get by calculation must match what you get by the diagram. What you get by calculation must match what you get by the diagram. Our next part now, last part says G is the midpoint of OB. G is the midpoint of OB. All right. So let's go on the diagram now. So G is the midpoint of OB. So let me show you now. Diagram will tell me where it is, man. Watch this. Watch this. Let me remove this. So remember that this was 6, 6. This was 6, 6 all the way up here. So the midpoint must be 3, 3 right here. That's where G is, you know. Halfway of 6, 6 must be 3, 3. Right? That's where that G must be. Midpoint. So determine the coordinates of G, but we can calculate it. Right? So OG, they want the coordinates of G. So find the coordinates of G, we can find OG. So part C, we can say OG is simply half of OB. OG is half of the full thing. So that becomes half of 6, 6, which is 3, 3. The question asks us what coordinates. So I have to put coordinates. So the position vector of G is 3, 3. Then the coordinates is written like this: G, 3, 3. Right? 3, 3 like that. And the last part now is for us to prove that a straight line somewhere. Prove that AG and C are on a straight line, meaning that they are collinear. AG and C. AG and C. So the points AG and C, and I'm going to draw them on the diagram now and show you. AG and C. See them here? AG and C. Show that they're on a straight line. AG and C. All right, let's do it down here now. AG and C. Watch it now. AG and C. We want to prove now. So part C2. C2. We're doing A, G, and C are on a straight line. So to show that AG and C are on a straight line, we need to use two vectors. Two vectors. Now look here, we have AC already, you know. So it don't make sense we go calculate AC. Any two vectors we can use, you know. So we can use AC as one of our vectors. So we're going to use AC, which we have already. And what was AC again? AC was, see there, minus 6, 2. AC was minus 6, 2. And after we use the AC, we're going to use something with the G now. So we're going to use AC and, which one you want to use? AC and, which one I want to use next? The AG or the GC? Which one you want to use? Guys, GC.
Yes.
GC?
Yes, sir.
All right, so we're going to use that and GC. But because we don't have GC yet, we have to calculate it. And GC, remember now, is OC minus OG. We don't know it, you know. Based on the diagram, the GC is negative 3, 1. Negative 3, 1, you know. That's the GC to go from G to C. It's the G here and C here, negative 3, 1, right? But let's calculate it. So it's negative 3, 1 is supposed to get. Let's see if we get negative 3, 1. So the OC, remember, is 0, 4 minus the OG is 3, 3. And this becomes, see there, you get the negative 3, 1. See, 0 minus 3, negative 3. 4 minus 3 is 1. So that's it. That's a GCE. So we're now comparing these two vectors. We're comparing this vector and this vector. And what we can see? This one is clearly 2 times this one. Is it? But what are the steps? You can see it now. What are the steps? We multiply this one by 2. Multiply up the smaller one to equal the large one. It's a large one. So we multiply this one by 2. Let's put it in red. Multiply this one by 2. Then we would get 2GC equals minus 6, 2. And then the two of them equal now. These two equal now. This equal this now. So we call them equal now. We can equate, right? So we can equate. And when you equate, you're gonna get that AC equals 2GC. All right. In order to get that AC equal 2GC, remember we're showing collinear, you know, it's collinear we're doing, you know. Look, remember it's collinear we're doing, you know. All right. After you get that, now you have to show the two things. So you underline the common point and you state the two condition. One, because AC equal to 2GC means that first thing condition is that AC is parallel to GC. That's the first condition. Second condition is that you must have a common point. So you state it. C is a common point. Once you're gonna do collinear points, that's what you have to do. You have to show these two things. For parallel vectors alone, you just show that. One is a multiple of the next. If we're gonna do collinear points, you have to show parallel vectors and a common point. So you need one more steps if you're doing collinear points. Parallel vectors and a common point. So the C is a common point. And since you have that, then you can write the conclusion and say, therefore, or that implies that the points involved A, G, and C are collinear. A, G, and C are collinear. And that is your answer right there. That's it. Remember the steps to show that they are collinear, guys. You need to find two vectors. You want to show that 3 points are collinear, choose two vectors. Most times you will have one of them already. So we have AC already. So because we have AC already, then we go and find another vector with the G. So we could use the AG if we wanted, or we can use the GC. We decided to use the GC. If you use the AC, it will work just the same. It don't matter. You still get two parallel vectors, but it don't make no sense to work out two new vectors when you have one already. You need two vectors with the 3 points. So because we had the AC already over here, we use that one here. And then because we never have any vector with the G yet, we have to calculate one. So we decided to calculate GC. Somebody said GC. We could have calculated AG if we wanted, right? We could have calculated AG if we wanted, but we decided to calculate GC. But you have to use one. You have to use another one with G in it. Because we have AC already, so either going to use GC or we're going to use AG. We decided to use GC. We could have used the AG if we wanted. We would still have gotten two parallel vectors with a common point. And that's it. And we have to write these two conditions or showing collinearity. Show that you have parallel vectors and state the common point. In this case, the common point is a C. And I normally underline it with the examiner sit up. All right. So basically, that's it. Always stay. But good?
Yes, sir.
Yeah.
All right. So you know what to do. You know what to do. Right. I don't have to tell you. Work these same questions over again. You have the handout, you have the video. Work the questions over again. All right. Work the questions over again. Watch over the video. Right. Work the question. If you've worked one question 2 or 3 times until you get it by yourself, that's what you do. So let's work these couple questions that we did over by yourself. On Wednesday, I'll do a number more questions for you. All right. I'll do some more for you and explain them. Between Wednesday and Sunday, you do the same thing again. Work them over by yourself. On Sunday, we'll do some more, and then I'll give you one to do for yourself. And by that time now, you should be fine. By that time, you should be fine. But I want you also to remember to use this must-know sheet. Guys, use this must-know sheet as a guide to remembering the thing, right? Use it as a guide to remember how you do each thing. Right? It's just an example. That's the main rule. For example, formula for finding midpoint is this: average. Right? Displacement vector is this: O times the last minus O times the first. Right? Position vector, the midpoint is this: average. It's an example where it is worked out. If you want to show that vectors are parallel, first thing you do is get rid of the fractions. After you get rid of the fractions and you multiply the small one to equal the large one, then you equate. See, the equating take place here. And if you want to state two relationship between two lines, one is going to be that them parallel and the other is some relationship of the length. can state the relationship directly, or you can put it as a ratio. If you want to show that 3 points are collinear, you need to show these two things, that you have parallel vectors and you have a common point. So you need 2 vectors between the 3 points. Show that them parallel in the same way. What is not on this must-know sheet are the steps that we use to show that the vectors are parallel. The steps, what are the steps? 1, get to the any fraction. 2, multiply up the small one to equal the large one. 3, equate and simplify. And by the time you do that, you will end up with an equation, for example, like this. That means that they're parallel. In the case of collinear points, you end up with an equation like this. And in the example that we did, like this. That means that they're parallel. In this case, the Q is a common point. So the two things there, parallel, and I have a common point. Therefore, the points involved are collinear. The points are collinear. All right. Do these things, you'll be fine. And notice that the question that we did today, we use a diagram to go from point to point. If you're going in the opposite direction to a vector, so for example, if a vector up so is u, and you're going this way, then that's minus u. If you're going the opposite direction to u, then it's minus u. And see that you can have a vector, and you have the whole vector is u, and you come to the midpoint, then the first half is half u, and the second half is also half u. Right? If you break it into thirds, you have a vector, and the whole thing is u. You break it into 3 equal parts, then this is 1/3 u, and the rest of it up here is 2/3 u. Stuff like that. All right, it's very easy stuff. And it's just how you go from point to point. When you have the vector diagram, just look how you go from point to point. Just look how you go from one point to another point, going along the vector direction that you know. If you have to go to the opposite direction to a vector direction that you know, opposite direction to an arrow, then you put the negative. Negative in vectors means you're going in the opposite direction. All right? All right, always stay.
Cool, sir. Cool.
Good.
Yes, sir.
No sure. All right. So no, just do what I tell you. No. Just do what I tell you. All right. Do what I tell you. Redo the questions by yourself. All right. Redo the questions by yourself, guys. All right. So we're gonna stop it there for today. I will pick it up back on Wednesday. So spend the time, practice these questions that we did. Look over the must-know sheet, right? And on Wednesday, we'll do some more practice and you'll get better. Progress before perfection. Progress before perfection. That's how it is. All right. Bye. See you all on Wednesday. Bye, Princess.
Wednesday.
All right. All right. Bye. Bye, everybody.
Bye, sir.
Bye-bye. All right, guys. I'm going to end it now. Okay. Bye. See you on Wednesday.